Hello and good afternoon. Good evening, ladies and gentlemen, and welcome to the Science Majlis online series of the Qatar Environment and Energy Research Institute. Before I start, let me just get my presentation up on the screen. Okay, so like I said, we are the Qatar Environment and Energy Research Institute. We are part of Hamad bin Khalifa University. And of course, we are under the wider umbrella of Qatar Foundation. We are a research institute focusing on the grand challenges of energy, water, and environment. Our Science Majlis today, the topic is the management and distribution of water resources in Qatar. And let me get on with the show. Okay, so what exactly is Science Majlis? So it's a community event we do, on a quarterly basis and more if we can. Of course, last year was different because of the situation that all of you are in. The pandemic, set us back a little bit, but I hope all of you are keeping safe and, all of you got your vaccinations and we are all ready to get back to life come summer. Okay, so it's Science Majlis, in the words of our executive director, Dr. Mark Vermeesh, is this. At QEERI, we truly believe in the mutually beneficial process of a two-way dialogue with the community. Not only does it provide a greater understanding of the work that we are doing, but these events also help raise awareness about the energy, water, and environment challenges in Qatar and across the world. And in turn, we're able to gain perspective on how the community perceives the impact of research in the country, which can further help us contribute to building and nurturing a research culture in Qatar. So from that, it is obvious that we hope today is an interactive dialogue. You are not here to listen to us or to our expert. We are in fact here to listen to you. We want to share a little bit about the work that we do in our water research, and we hope to hear and go back with what you want to share with us and see how we can incorporate those ideas and those thoughts into our everyday work. Right, today's speaker is this incredible lady and scientist, Dr. Jenny Lawler. She's the Senior Research Director for the Water Center, and this is a quick introduction of her. If I go into detail, I'll probably have to use the entire 1.5 hours, so this is just a little bit in short. So for the past 15 years, Dr. Lawler has worked in the area of water and environment. She's passionate about the provision of safe water for all as a basic human right and believes that research in this area can have a positive impact on policy development to assist in protection of human health and also in the development of products and technologies that can be instrumental in improving the safeguarding of water resources and energy efficiency, effectiveness, and cost of water treatment. So Dr. Jenny, in fact, moved to Qatar fairly recently in 2019. I mean, usually we wouldn't call it recently, but considering the year that was, it probably almost seems like she moved last year. But she has been such an incredible asset to QEERI and to the water research community at large in Qatar and the region. So that is a little bit about her. Today, we're also supported by an incredible team from QEERI. We have Dr. Dima Al-Masri, Dr. Victor Kochkudan, Dr. Yahya Manavi, and Ms. Nasma Mohandes running the show behind the scenes. And of course, I forgot to introduce myself. I am Duraz Kundumal. I manage the PR, communications, and outreach at QEERI. So a lot of the emails that you guys get probably come from my desk. Once again, thank you so much for your continuous support to everything that QEERI does. This is our 10th year of being in existence. So this is our 10th year of serving the community and the research field in Qatar. And this year is also big for us because later in the year, we will be having our second flag conference, which in 2019, it's called the International Conference on Sustainable Energy, Water, Environment Nexus. And it will be in November. So usually during our IC7, we also have activities for students and university students and researchers and beyond. So please keep your ears and eyes peeled on to the newspapers for that. We've already announced our call for papers. Reach out to us anytime if you need more information. All right, just some rules and guidelines quickly before we start. Of course, you will have noticed your microphones are muted when you join the session, and only the team that's either myself, Dr. Jenny, or the team behind can unmute you. We encourage you to ask questions by tapping them into the Q&A tab, which is on the bottom right corner of your screen. We will obviously aim to answer as many questions at the end of the webinar today. It is being recorded and it will be shared on HBKU's video portals. If you're posting about the event on social media, and I hope you will, please use the hashtag QEERI webinar. The idea is that we last for 1 hour. but sometimes we get more questions, so it sometimes goes beyond that. You can manage how you view the screen by clicking on the three windows, which should be on the top left or right corner of your screen. All right, here is how you can ask us the questions. At the bottom of your screen on your laptop, you will have these two buttons, and next to that there are three dots, which has a Q&A tab. I urge you to please use that so that we can collate the questions at the at one location and make sure that we answer all. And when you do, please click on all panelists so that the panel can see the entire panel can see your questions and we don't miss anything. And this is how it looks on the phone. So you, at the bottom of the screen, you have the three dots. Once you click that, you have your Q&A there, and you can ask us questions. All right, that's it from me, Dr. Jenny. If you could please switch on your camera and microphone, and I can hand it over to you.
Yes, I will. Okay, so I should be visible now, I hope. Fingers crossed.
Yes, we can see you now.
Okay, fantastic.
And I will just pass on the presenter rights so that you can jump straight into it.
Okay, thank you.
All yours.
Thanks. I'm just trying to share the presentation now. So good afternoon, everyone, or good evening, everyone. Let me try to share the screen here.
We can see it now.
You can let me know when it comes up properly.
We can, we can see the PowerPoint now, and I think in a second it should go into the presentation view.
Okay.
We can see it with the notes, so I think if you change your display settings quickly, we should.
Yeah, hold on. Display settings. Now, is it correct?
There's a bit of a lag for me, so yes, perfect. There you go, and all yours, Dr. Jenny.
Okay, fantastic. Thank you. Welcome everybody, and thank you, Dilraz, very much for the lovely introduction. As Dilraz explained, I moved to Qatar in late 2019, and I moved here from Ireland, which obviously has a very, very different water scenario than Qatar has. So obviously Ireland is quite a wet country, and very much in contrast to Qatar. So it's been a fantastic year and a half here in Qatar, despite COVID, despite everything else. It's so very, very different to live in a desert environment and really get to look at the challenges associated with water in this kind of environment. So I'm very, very happy to be here and to be hosting the Science Majlis tonight with the team here. I'm going to talk a little bit about the management and the distribution of water resources in Qatar. And whenever I meet anybody and I say, oh yes, I'm in water research, they kind of look at me like I have 10 heads. But one of the first questions that people always ask me is, well, is the water safe to drink? Or, why does the water taste so bad? So hopefully I can, kind of maybe try and address some of those questions this evening. And as Dilra said, what we really, really want is your feedback, your input, lots and lots of questions in the Q&A, and we'll try and take all those kind of things on board. So just to give you a little bit of information, those of you that aren't familiar already with QEERI, Qatar Environment and Energy Research Institute, we have a absolutely fantastic team. We've got over 130 scientists and engineers working at QEERI. And Dilraz introduced me as a scientist, but I'm actually an engineer. I'm a chemical engineer, but I won't take too much offense at that. And we are located in Education City, and we have a fantastic facility, over 4,000 square meters of absolutely state-of-the-art laboratory space. And we also have a huge outdoor testing facility. So as you can imagine, the environment in Qatar is very, very challenging in terms of heat, humidity, dust. So for technologies to actually come into this environment and to work, it's really, really critical that they are tested in this environment, because it's very, very different to other parts of the world. So we're very lucky to have these fantastic facilities and to be so well supported by Qatar Foundation and by Hamad bin Khalifa University. So we are structured as QEERI. We try to address the grand challenges of the environment, and as such, we're structured in such a way that we look at the different areas and try to address them in a holistic manner. We look at the challenges associated with energy and the transition to more sustainable energy in the region and globally. The Water Centre, then I'm the Senior Research Director of the Water Centre, as Dora said, and we look at all of the challenges associated with water, from the first drop to the disposal. And we have our Environment and Sustainability Centre, our Natural and Environmental Hazards Observatory, our Corrosion Centre, and we have an Earth Sciences programme, and we have a Sustainability and Policy programme, Policy and Economics. And we're fantastically supported by our core laboratories, micro and nanofabrication facilities, and as I mentioned, our indoor and outdoor testing facilities. And we are very proud to have recently received ISO accreditation for our facility. So we're now accredited under ISO 14001, 45001, 9001, which reflects all of our commitment to sustainability, to environment, to health and safety, and then also most recently ISO 17025, which accredits our laboratories to perform testing, and it shows that we're right up there with the most the top laboratories across the world. So this is something that we're really very proud of. So QEERI Water Centre, our focus is really to look at water resources and how they can best be managed, how they can be looked at more sustainably. And we look at three kind of main areas, and I'll go into them all in a little bit more detail this evening. So one is the water resources. So what are the resources for water in Qatar? So, I mean, when you turn on your tap, water comes out. Is that a water resource, or where did it come from originally? So what we look at is what are the traditional and the non-conventional water resources that are available in this country, and how they could best be sustainably managed. We look at the two kind of main areas of water treatment then, so that's desalination of water, removing the salt from water, and how that could be done in a more energy efficient manner. And we look as well at wastewater treatment and reuse, and particularly in the being able to look on these kind of water resources as resources themselves. So trying to influence policy on how water can best be managed and conserved and made more sustainable. So we have a real focus on how science and how data and how engineering can influence policy to make the world a more sustainable place. So let's do a little warm up about water. So first of all, we know that 70% of the world is covered in water. We are a lovely wet planet when you compare us with the other planets in the solar system. So my question to you, to make sure you're all awake, if you could type in the Q&A, what percentage of that water is actually fresh? So I'll give you a couple of minutes to see if you can come up with a few answers, and then I will give you the answer. And in Qatar, we do not really have any freshwater resources. So in comparison to, you know, some people here might be from Europe or the US, there are lots and lots of freshwater resources. So there's rivers, there's lakes, there's underground water and groundwater. But in Qatar, we don't have any of that. So there are no rivers, there are no lakes, there's very, very small amount of rainfall. We do have groundwater in Qatar, but it is, the vast majority of it is salty. So it's not suitable for drinking, not really suitable for irrigation. Okay, so we've had a few answers come in there in the Q&A, and a few of you have actually got it right, which is amazing. So the percentage of freshwater is only 2%. So it's very, very small. So the vast majority of the water on the planet is saline, or it is in some other way undrinkable. It's not fresh water. Now, out of that 2%, what might surprise you is that most of it is actually not available to us. 1.6% of that 2% is locked in the polar ice caps and in the glaciers. So out of all of that water that we are surrounded by, only 0.4% of it is fresh and is available and reasonably ready for drinking. So for more than 7.5 billion people, this is a little bit challenging. So what we want to look at is, how can you manage this? How can you manage this fundamental kind of issue? So another question, is this fresh water really fresh? So a real question that a lot of people have is, can you reuse water? Can you recycle water? Is it really clean? And the reality is that the water that's on the planet is just cycling around. So whatever fresh water that we have now, we had it millions of years ago. It's essentially the same water, and it's gone through processes of evaporation and condensation. It has picked up pollutants. The pollutants have been cleaned out of it in natural processes and in man-made processes over millennia. So, at the end of the day, all of the water that we have or drink or use, it's all been somewhere else before at the end of the day. So, so that's a little just something to keep in the back of your mind as we look at water resources and whether or not they're good resources or not. So some questions that people sometimes ask me relate to how can you be more sustainable in terms of the way that you use water, and what should you do differently in the home, for example. In terms of home use, so actually the statistics show that the average family, a 2+2, will typically turn on the tap about 70 times a day. So that's maybe something to think about as you go about your day. How many times are you turning on the tap? How much water are you using? Do you need to leave the tap running? And another little question for you, if you want to type in the chat window. When you brush your teeth, how much water do you think you use? So just envisage yourself now, morning or evening, brushing your teeth, and how much water do you actually think you use? So we have a few answers coming in there. So in terms of volume, so typically it takes the average person maybe 2 to 3 minutes to brush their teeth. If you turn on the tap, wet your toothbrush, leave the tap running, brush your teeth, you will waste about 4 liters of water. If you wet your toothbrush, turn off the tap, brush your teeth, and then rinse your toothbrush, you will use less than 1 liter of water. So that's one thing that you can do. You have to think about when you leave a tap on. It's actually a typical tap is going to depending on the age of the tap, it can generate up to maybe 2 or 3 liters a minute, depending on your tap. And the same with toilet flushing, for example. If you have a toilet that has a little leak in it so that the water is flushing down, that can waste thousands and thousands of liters per year. And it's not only about water sustainability, I suppose, it's also about cost. The water is reasonably expensive here in Qatar. So if you want to keep your karma bills down, it's definitely something to think about. So we had a question there, what about the shower? So the same thing, a shower can use about 4 to 5 liters per minute in the newer kind of water saving showers. Older type showers and power showers can use even more. It is thought that having a shower, cutting down the time of it to maybe 4 or 5 minutes, if that's reasonable, definitely a better approach than having a bath. It'll use less water. But these are necessary things. Absolutely, but we have to kind of think about what way we can try and save water in the home. So there are a few different water saving devices that are available that you can look at installing in your home. Devices that go into your toilet. You can get A-rated appliances, washing machines, dishwashers, things like that. But it's definitely something we need to think about. So there are a huge number of stresses on water. So if you think about all the different things that use water, the household is the very obvious one, and drinking and showering and hygiene. But there are many, many other activities that use water. So one of the most prominent is probably agriculture. So in agriculture, not just in irrigation of crops or watering of crops and gardens, also in things like farming, the meat industry, the dairy industry, these all use massive amounts of water. We have industries like textiles. So for clothes, it takes a huge amount of water to make one item of clothing, a huge amount of water from the time you look at the processing of the fabric. So if it's a cotton item, you know, there's a huge amount of water used in cotton production. Then you have the textile production itself, you've got the dyeing or the bleaching, you know, a massive amount. So there's so many different industries that need to look at how they can be more sustainable in terms of water. And you know, these are all kind of stresses pulling on this little 0.4% of the global water supply. So these all have to be looked at. And if you look at the global stats in terms of water stress, you can see Qatar there on the screen, and it is an area of extremely high water stress. So as I said, we've got virtually no fresh water available here for the population. 1 in 3 people statistically globally do not have access to safe drinking water, and that does not only apply to, you know, sub-Saharan Africa. It's prevalent really quite across the world, and the demand for water is really growing, and it's projected that over 40% of the world's population will live in water scarcity areas by 2035. And that's driven not only by the effects of stress and over abstraction and the growing population, but also obviously on the effects of climate change, which are definitely increasing the effects of water stress. So there's a lot of factors that influence the freshwater supply. Here in Qatar, obviously the climate and the terrain have a huge impact. And we also look, you know, globally at different types of infrastructure. So for example, there's been a huge amount of controversy recently about the GERD Dam, which has looked at the sustainability or the potential future availability of water in Egypt. And that also ties into things like government. So how stable is a region, what sort of governmental practices are in the region, whether there is policy for water sharing, cross-border water. Farming practices will have a huge impact. So in Qatar here, quite a lot of the agriculture actually relies on groundwater abstraction, so taking groundwater out, and we are taking out about 5 times more groundwater in Qatar than the natural recharge rate is. So that is obviously highly unsustainable, and it is not recharged by the rain. So what happens when you pull out the groundwater in these wells, you essentially pull salty water in from the surroundings of Qatar, which makes the groundwater more saline, which then makes it more difficult to treat. It requires more energy so that it can be treated before it's used for irrigation, and the whole situation becomes worse and worse. And something really fundamental as well as the public attitudes to water will influence how much fresh water can be supplied or where that fresh water supply can come from. So what are the public attitudes to conservation, to sustainability? And we try to look and touch on kind of all of these areas. It's well accepted that this region is the most water stressed in the world. It hosts 12 of the world's most water scarce countries. We are home here in the Middle East North Africa region to 6% of the global population, but we only have 2% of the global water supply. So that's a huge issue. And the water withdrawals exceed the sustainable limits. And I mean, we're very lucky in Qatar here that we have, you know, really fantastic infrastructure. We've got a very high GDP. There are other countries in the MENA region that obviously are not so in such a good situation. So we're obviously very privileged to be here in Qatar, but at the same time, this is a water scarce region. We are very reliant on technology for all of our water needs, and it is something that, you know, we are vulnerable in this way. In terms of where we sit, so if you look at the different countries that are in this region where we're water stressed, you can see Qatar is up there. Only Kuwait and the UAE are more water stressed than Qatar. Qatar is well under the limit of absolute water scarcity. There is less than 500 meters cubed per year of water available per inhabitant per year in this country, and it is that availability itself is expected to halve by 2050. So it's really critical. It's something that has to be done. Something has to be done to make this whole thing more sustainable. So in 2015, there was a World Economic Forum, and the MENA region leaders were asked, which global risk is your region least prepared for? Certainly nobody was thinking of a global pandemic at that stage, but I think Qatar showed it was, quite well prepared for that. The majority of the respondents identified a water crisis as the greatest threat to the region. And, when you look at I'll go into more detail on the actual technologies that we're relying on, we're really, really vulnerable to water stress and to infrastructural issues and potentially other issues that could threaten the region. So even greater than any sort of political instability, greater than any sort of blockade, anything like that, the water crisis is really what we are least prepared for in this region. So I'm going to talk a little bit about where our water comes from, where it goes, what happens to it, and what I'll do then is I'll just give a bit of a brief overview of some of the research that we do that hopefully contributes to enhanced water sustainability in the region. So there are probably quite a lot, the population here in Qatar is hugely expat dominated, so I imagine that we have quite a lot of people in the room that are from regions where there are freshwater resources. So I want to just say a tiny bit about where your water comes from if you live in a country like Europe or Ireland or the US, for example, where there are freshwater resources available. So when you turn on your tap, your water has been treated and it has gone through a drinking water treatment plant. And the source might be a reservoir, or it might be a river or a lake, or it might be groundwater. And it goes through a few different processes to basically try and remove any contaminants from it. So they could be solids that are present, silt, sediment, and different bacteria pollutants are really the focus of drinking water treatment, to make sure that that drinking water is safe to drink. So you can see it goes through a number of different processes, mixing, flocculation. There are some chemicals added to it to make sure that any solids that are in there will flocculate or stick together, and then they drop out in terms of their sedimentation. There's usually a filtration step where these things are removed, and it is always some sort of disinfectant is added. And what that does is it makes sure that the bacterial contamination or viral contamination in that water is reduced to an acceptable level, and it also protects the distribution system downstream of the drinking water treatment plant. So as it gets distributed to the different homes, that you don't have further bacterial growth from the distribution. So when you get it to your home, it is nice and clean. And the only thing is that sometimes people with these kind of plants, they'll complain that there might be a bit of a smell of chlorine from their water. And what that is, it's the disinfectant, and it's made sure that the water is safe by the time it reaches your house. So the situation in Qatar is very different because we don't have these freshwater resources, and we are almost entirely reliant on desalination. So we rely on the seawater. So one of the first things that we have to look at in terms of water resources is that the sea is our water resource for the most part. So we really need to think about how we treat the marine environment. And the desalination process itself is not hugely environmentally friendly. And then there are a lot of anthropogenic or human activities that are also quite detrimental to the quality of the marine environment. So obviously there's a lot of shipping in this area. 80% of the goods that move around this region are by ship. We also obviously have a huge oil and gas industry in this region, so there are ships circulating that there's potential for oil spills. That all goes into the marine environment. And then anybody that kind of walks along the coastline here in Qatar, we have a huge problem with a lack of respect for the environment in this country, and you will see a huge amount of trash and debris in the marine environment that is obviously caused by human activity. So this is really a problem. We need to protect this environment because it is the resource that we rely on for our drinking water. So what about the sea in Qatar? Another thing that people will notice when they go swimming here, not only is the water much warmer than other places in the world, but it's also very, very salty. And you will have noticed that, you know, it kind of stings your eyes and that kind of thing. So if we look at the little map of Qatar, you can see that I've got two numbers on there, 45 grams per litre on the east coast of Qatar and 57 grams per litre on the west coast. And that refers to the salinity of the seawater. So the seawater around here is very, very challenging. It's about twice as saline as the sea in the Mediterranean or Northern Europe. And this makes it more challenging to desalinate than the water that you find in other places of the world. And the reason for that is that the Gulf is quite shallow. You've got a lower levels of changeover in the water. So we are producing virtually all of our water by desalination, and we're up to over 600 million cubic meters per year in the production of the desalination plants in Qatar. So this is something that really, it has to be made sustainable. So this is something that we look at. So in terms of how do you desalinate water, how do you remove the salt from water? And if we look at the natural way that this happens, so I have two figures up there, natural distillation and natural purification. There's two main ways that we desalinate water in this region, and one is by thermal means, so using heat. So this looks at being analogous to the natural water cycle, where you have evaporation, so the heat of the sun evaporates the water from the sea. It is moved around in clouds and it falls as precipitation, and that is fresh water. And what has happened there is basically an evaporation condensation process, and with the evaporation process the salt is essentially removed and then it condenses and it's fresh water. And that's the same thing basically that's happening in a thermal desalination process. So about 75% of the desalination plants in Qatar at the moment work on this basic principle of thermal desalination. The other way that is kind of reasonably well established is membrane desalination processes, and the most common that you'll find here, so this accounts for about 25%, is reverse osmosis. So what that does, it's analogous to what's happening in our body when we have our kidneys basically filtering impurities out. It's very, very similar to that. So a membrane is basically a dense material that the water can be pushed through using high pressure, but the impurities and the salts will not go through. So that's kind of the basis of the two main ways that we will look at desalting. So in both cases, what you need is the seawater feed, you need some sort of energy input. So for a thermal desalination process, it's going to be heat. And for a membrane desalination process, it's typically going to be powered by electricity. And what you will get out is you'll get one stream that's your fresh water, and you get one stream that's the brine or the very, very salty reject. So the salt has to go somewhere. So you end up with a very concentrated salt stream. And what typically happens with the desalination plants at the coast is that gets back into the sea. So that is one thing to think about in terms of the environmental friendliness of the desalination process. So when you are taking the seawater out, you're taking the salt out of it, you're putting the salt back in, and you're using the fresh water. You have to, this is something that has to be managed very carefully when you look at designing the desalination plants. You've got to make sure that when you're putting that salt, concentrated salt stream back in, that number one, the temperature that it goes back in at is not going to be detrimental for the marine environment and for the animals that live in the sea. And you have to make sure that you're not causing these really high point sources of salinity that can be detrimental to the marine environment as well. And in both of these cases, there are a lot of chemicals that have to be put into the seawater before it can be desalted. And one of the main reasons for that is corrosion and fouling. So we have to put chemicals into the seawater to try and mitigate against corrosion and fouling in the desalination plants. So all of those chemicals go into the brine and they go into the sea. So these are things that QEERI is also looking at, and our last Science Majlis looked in detail at the issues of corrosion in Qatar and in this challenging environment. So this is what we're doing when we are desalting or desalinating water, and this is what you will receive to your house. So that's one thing. So all of the water that comes to your house, obviously, or goes to industry or goes to farming, it's going to be used, and then it is going to go to some sort of collection system, and it is going to be then termed wastewater. So after it's been used, you know, we receive it lovely and clean and fresh, then we use it and it goes to waste, and then it has to go through a wastewater treatment process. So the figure on the screen is basic wastewater treatment process, and that can apply for both municipal wastewater, which is what we call the wastewater that comes from your household, which is obviously a combination of water from flushing the toilet, from showers, from cooking, and also industrial wastewater. So most industries use water. You know, if you're looking at even animal husbandry, for example, you have to spray water to cool down the animals. You've got to wash down the animal houses. In food production, in laundries, in car washes, in paper manufacturing, and recycling facilities. But there's huge amounts of water used in all these things, and they all go essentially to the same place at the end, and that is the wastewater treatment plant. So Qatar has had huge investment in wastewater treatment, and the facilities that we have here in the country are typically state of the art. And the vast majority of the plants treat the wastewater to a tertiary level. And the way it works is that first kind of big solids are removed, then it goes for secondary treatment, which is mainly biological treatment. And what that does is it breaks down the organic material that's in the wastewater. So we look at things like the chemical oxygen demand and the biological oxygen demand of the water, and they have to be reduced to certain levels. And there are levels of nutrients that also have to be reduced. So things like nitrogen and phosphorus have to be removed before the water can either be disposed of or reused. And in terms of tertiary treatment, then the water is actually treated to a very advanced level. There are quality regulations that are put in place, and you know, before that water can be discharged into the environment or can be reused, it has to meet these quality parameters. So the wastewater treatment plants are very advanced in terms of technology, and we look at kind of trying to make them either more efficient or looking at particular targeting of contaminants that might not be regulated for yet, and I'll say a little bit more about that later. So one of the key questions then that people ask is the drinking water safe? So the drinking water treatment process is really very, very robust. The regulations are very, very good. And the distribution system here is very similar to what you will get anywhere else in the world. So in most places in the world, you will turn on your tap, you will take a glass of water and you will drink it. For the vast majority of people in Qatar, they don't do that. They don't feel confident turning on their tap and taking a glass of water. And there's a few reasons for that. So one is temperature. So for most of the year, when you turn on your tap and you get a glass of water, it's warm, and that's not typically palatable. But what I will say is that by the time the water reaches your household, it is perfectly safe. It's been treated to a hugely high quality. It's been desalinated, and then the minerals that are necessary for taste and for the water not to be aggressive in the piping system. So it has to have things like hardness, alkalinity added back into the water, and then it goes out into your distribution system. It's got the same kind of disinfectants that we put in anywhere in the world to make sure that it's free from bacterial contamination. But what happens is it gets to your household and it goes into your water tank on your roof. And by the time it goes in there, it's no longer the responsibility of the utility company, it's the responsibility of the household. So unless you get your water tank cleaned reasonably regularly, then you are obviously putting yourself at risk. If you look after your own household water infrastructure, so your own water tank should be regularly cleaned and inspected to make sure that it is even visually clean, then your water is perfectly safe if you live in a villa. If you live in an apartment block or a shared accommodation with a shared water tank that you don't have control over, then I would say don't just drink the tap water. It's probably perfectly fine for cooking and for boiling, for making tea and coffee, but unless you have good control over it, maybe it's best, and that's the reason why a lot of people in Qatar drink bottled water. I can personally put my hand up and say I live in a villa and I have been drinking the tap water here for a year and a half since I got here and not had any issues at all. So it's just a case of really taking responsibility for what is under your own remit, which is your own water tank and your own household. But that's a question that I get all the time, so I just wanted to put it out there. But like in any country in the world, there will always be failures and isolated incidents of failures in the water treatment and in the water distribution system. This is the same in every developed country. You know, so before anybody kind of says, oh, well, one time I turned on my tap and the water wasn't safe. Yeah, I mean, that happens everywhere in the world. So treated wastewater. So what is the story here with treated wastewater in this country? There are countries in the world, so for example, Singapore, where all of the wastewater is treated and it is reused to the highest capacity. So I just have a quote up there on the screen. Water should be judged by not by its history, but by its quality. So if we think about it, every single drop of water that we use, it's all in a cycle. Even if it goes back into the sea, we take that seawater and we treat it and we desalinate it and then we drink it. So it's all in a cycle. And when you buy bottled water, you are buying desalinated water. So think about where it comes from. It's the vast majority of the bottled water that you buy here, it's not being imported. It's being desalinated in Qatar and it's being bottled, or it's being desalinated in the MENA region and it's being bottled. And it's the same processes, it's the same water. So it is, you know, it's really important to think about this kind of water as a circular process. So, you know, understanding what water quality is, that really is you know, something that we try and use to drive policy. So if you look at the figure that's there, you know, drinking water 5-star standard, we implement regulations that are, you know, the absolute best practice globally. And then it gets used, as I said, and it is turned into wastewater. So it's what we do with it after that should determine whether or not it can be used again. You know, we can treat it quite easily and get it back up to that drinking water standard. So that's something that, you know, a public perception issue that needs to be examined, because this is a really, really important water resource and it shouldn't be wasted. So if you look at what we do with it here in Qatar, so Qatar, we've got a population of 2.8 million. We've got a really, really tiny annual rainfall, just 82 millimeters per year. So it's a tiny rainfall. So TSE generation, because of the increase in population and the increase in wastewater treatment plants that have been installed, I think there are about 30 wastewater treatment plants now under the remit of Ashghal around the Greater Doha area. It has increased more than 3.5 times over the past few years. Back in 2016, we were generating over 200 million meters cubed of treated sewage effluent, and that only refers mainly to the municipal wastewater that's collected from houses. And this is what we do with it here. So if you look at the 2016 numbers, over 60% of it, over 60 million meters cubed of it was used for agriculture. So in terms of agriculture, it's mandated under Qatar National Vision 2030 to really increase the use of treated sewage effluent, because it's recognised as a really important resource. You can use it here for irrigation of fodder, so for crops, for feeding cattle. You can use it indirectly in agriculture, but it's not widely used for direct irrigation of crops. And there are social and cultural reasons behind those kind of regulations being in place in this area. It is worth pointing out that those type of regulations, so not being able to use it directly in crop irrigation, they're not in place in other places in the world. So when you eat imported fruit and vegetables, for example, there's quite a high chance that what you have bought in the supermarket has been irrigated with treated sewage effluent, because it's a very, very common practice in other parts of the world and in other parts of the MENA region. So that's something to bear in mind. If we look then at the next largest use it is injection into the aquifers. So as I said, the groundwater is stored in what's called aquifers, spaces in the subsurface where you have pockets of water. So we have had quite an aggressive program of re-injection and rehabilitation of the aquifers. But this is challenging, and we've done a lot of research in QEERI that's looked at what's happening with the aquifers in the region. We have seen that with groundwater abstraction, it's actually causing land subsidence, which is actually affecting the surface of Qatar itself and is a major risk to the coastline, to coastal erosion, to the changing coastline, and also to infrastructure, so such as the new pipelines for the mega reservoirs project, to other underground structures. This can be problematic. So injection into aquifers is a big focus, but with questionable results, I would say. And the next biggest is irrigation of green spaces. So you will have noticed, if you've gone into any of the public parks, you will often see, you know, irrigation, and you'll see signs up that say that it is being irrigated with TSE, or with treated sewage effluent. So this is a big use. There are a number of lagoons around the country where treated sewage effluent is discharged, and there's been a big focus in recent years on rehabilitation of lagoons around the country that had previously been of low quality. And there's a big focus now on turning these into public amenity areas, which is fantastic. And a tiny amount then as well is discharged to the sea. So this is what we are currently doing, and what we would like to do under Qatar National Vision is try and use more of the treated sewage effluent for better and more sustainable and higher value purposes. The reason being, it looks like there will be a surplus of treated sewage effluent, surplus to demand, by 2030. So we need to look at alternative uses for this and how we can do it. So this is just an example of one of the wastewater treatment plants around the Greater Doha area. Really, really high tech, a lot of investment. The wastewater treatment is by Ashghal, the utility, who bring in companies that have design, build, operate contracts. So you will have noticed that actually not all of Doha is connected to the sewer network, which is something that does need to be looked at in terms of infrastructure. So a lot of sewage is actually tankered around the city, and you'll see sewage tankers and also drinking water tankers moving around the city. So there's huge investment and huge construction going on in terms of improving the infrastructure around that. But the TSE is treated to a very high quality. This is high grade reclaimed water. And the other thing that you will get from a wastewater treatment plant is the solids. So the biosolids that come out of that wastewater treatment plant are something that are very, very widely used globally as a fertilizer. So they are high in nitrogen, they're high in phosphorus, high in potassium, and well suited to agriculture and to soil amendment and to improving the qualities of soil. And Qatar has to import a huge amount of soil and fertilizer from abroad every year. So really this is another resource that comes out of the wastewater treatment cycle that has to be looked at in terms of sustainability. So the way that we're looking at reusing wastewater at the moment, so one of the really interesting uses that's been mandated by Qatar National Vision is the use in district cooling. So if you live in areas like the Pearl or in West Bay, you will be aware that you have district cooling. So you don't have your own air conditioning system in your house, for example, or in your apartment. And the way that works is cooled water, or very cold water, goes through the Qatar cool plants, and it ends up circulating the cooling around the district. And what that is now mandated to use is treated sewage effluent. So this is a very good use of this as a resource. But the key thing is that we have to make sure that even for this, that it is treated to the perfect quality to avoid any kind of growth of bacteria. So one of the key things that we look in QEERI is actually looking at removal or capturing of phosphorus during the TSE treatment, so that it can be really, really suitable for use in district cooling. because of the increase in agriculture and in the focus on food security in Qatar over the last few years, there's been a huge increase in not only the amount of wastewater that's generated by the food industry, but also in the amount of treatment and reuse in the food industry. And this is something that's really fantastic. So a lot of you will have visited Baladna Farm, and you can see examples of the water reuse process. So the next time you visit, try and have a look at that. So where the water that is used in the animal and in the milk processing plant is actually captured using a very innovative system of floor drainage and treatment and biological treatment and filtration, and then it can be reused. So it can be reused even in things like spray cooling of the animals in the hotter months of the year. So really, really great innovations that we see proliferating around the country. So that's kind of a whistle-stop tour of the basics of what is happening to water in the country. So we've got desalinated drinking water. At the end of the day, that all ends up going to the wastewater treatment plants. We've got municipal wastewater from our households, and we've got industrial water, which I haven't talked about at all yet. So what I want to do now is just give a little bit of information on what QEERI can actually do, or what are we doing at the moment and how we're trying to help. So we are a research institute. We're focused on market-driven research. And how we can actually help the country. So I have a picture there of the water centre team. Most of them are pictured, and that picture was taken at Dukhan on the west coast of Qatar, where we have a desalination pilot system, which I'll talk about in a little bit. So we have a big focus on improving the efficiency of desalination plants is one thing, but also the protection of desalination plants. So as I said, we're in a vulnerable region. The seawater is our water resource. And we have to try and see how we can protect that. So for example, I'm going to talk about our desalination pilot now and how to improve drinking water production. But we do a lot of other things about desalination that I won't have time to touch on everything. So I'm going to apologize in advance to the team members who I won't be able to talk about all of their research, but just a little bit of a few different things. So as I mentioned, the two desalination processes that are really common here are thermal and membrane. The thermal desalination processes have the absolute biggest foothold, and the reason for that is that the water is basically produced as a byproduct of the electricity generation process. So when you have electricity generation here, it's fossil fuel driven. Obviously, you've got big gas turbines that are being used to generate the electricity for the country. And what they do is they produce heat, and that heat is then used in the desalination process. So it's an evaporation condensation process similar to the natural water cycle in the world. And what happens is the water is heated up, it's boiled basically, it evaporates, and then it goes to be condensed. And then it has to be remineralized, and that's basically what comes out to your house. So what we've done is in QEERI Water Centre, we have looked at this desalination process and identified some ways to try and make it more energy efficient. So thermal desalination processes use a huge amount of energy, far more than membrane desalination processes, which is why there's a renewed focus on membrane desalination processes, and they're gaining a very good foothold in the region, and they're very popular in areas that don't have a huge oil and gas industry. So in Europe, you'll find a lot of membrane desalination processes, for example. So the energy requirement for thermal desalination is about 3 to 4 times that of reverse osmosis or membrane desalination. But and you might say, oh, well, we should move towards solar energy in this region, and then it'll all be focused on electricity. But the reality is that going forward for the next 50 years, we're still going to be hugely reliant on fossil fuel-based energy production in tandem with a move towards more renewable solar-driven energy production. So there is a real need to look at the thermal desalination process and try to make that more efficient. And that's what we looked at here in the Water Centre. So looking at trying to kind of make the process not only more energy efficient, but also more water efficient. So just to give you a kind of a brief overview of this, we've installed a pilot plant at Dukhan It's at the QEWC site. So we signed a 20-year agreement in 2019 with QEWC, Qatar Electricity and Water Company. So we're really, really privileged to have this agreement and have access to this as a site. So we have a big warehouse that was given to us by QEWC, and the scientist that you can see in the photo there is Dr. Abdelnasser Mabrouk, who along with his team developed this patented technology called it's a membrane MED with absorption, which is kind of a novel multi-effect distillation process. And we were able to install this in the facility at Dukhan. And you can see a few of the team there in the picture in the control room of the MED pilot. And this has been operating for a year now. It was built in Turkey and it was shipped to Qatar and it was installed. And what we have been seeing with this desalination pilot is that we've essentially achieved 30% lower in the unit water cost. So in the capital expenditure that is necessary for the installation of the plant, in the energy that's required to run the plant, these have all been reduced in various different ways by this novel design that the team have implemented, and this has led to an enhancement 30% lower in the unit water cost, so for production of the desalinated water. So this is something that we're extremely proud of, and where we are looking at going with this, you know, as I said, we've been operating for a year now. We've got a lot of really interesting ideas within the Water Centre for how we can improve this process more and more, how we can try and make the transition towards solar-driven desalination, how we can try and reduce the environmental impact of the desalination plants on the marine environment. So can we look at looking at the brine treatment, for example, squeezing more water out of the brine, making the whole process more environmentally friendly, avoiding the issues of corrosion and scale, trying to use less chemicals in the process. So we have a really fantastic team that are working on this, and a really fantastic team of collaborators, and it's something that we're very, very positive about. Just to move on to another case study, so something that is really, really hyped in this region is water from air, so air to water generators. And there are a few of these dotted around the place. So for example, if you go to the Olympic cycling track, at the start of the Olympic cycling track at the Qatar University metro station end, you will see that there are 3 air to water generator machines there. And what is basically happening when, particularly in a country like Qatar, we know it's humid here. This humidity in the air can be captured mechanically, and it can be condensed, and it's basically distilled water. So it's basically the air is going through a distillation process to capture the humidity in the air. So it's really, really interesting area, and it's something that Qatar really wants to look at. But what we've been really focusing on in QEERI is, well, what are other kinds of sources? What a part of this process, if you look at what's happening in air conditioning, when you have air handling units, you're doing the first part of this already. So you know that when you have your air conditioning system, it's sucking in the air, it is cooling it, the humidity is being removed. You'll always see from an air handling unit, there'll be a drain somewhere where the water is draining, and that's the humidity that has been removed from the air by your air conditioning system or your air handling unit. So what we looked at in QEERI was, well, this is actually a really valuable, again, non-conventional water resource. And we had looked at some previous studies by collaborators and other people around Qatar and globally. And the amount of air conditioning condensate that is produced, particularly in commercial buildings, so where you have, you know, 10 or 12 air handling units on the roof, in some places even more, the production of this air conditioning condensate, which is essentially very high quality distilled water. It's the same thing as the air to water generator. You've got the humidity, it's being taken out of the air, it's being condensed, and it just gets discarded. So in the interest of sustainability, this is something that we started looking at in QEERI. So this really high quality water does require some treatment before it can be reused. And what we looked at was, what was the optimum treatment? this water, because it's distilled, it's quite corrosive, so it needs an anti-corrosion unit where various different changes can be made to things like the pH of the water, and we look at filtration to make sure that the water is free from any particles that might pick up on the way, and we disinfect it using a variety of different technologies. That could be ozone or it could be chlorination, and then it can be reused. And this is something that we have developed over the past number of years in QEERI. We had an exhibition there recently, Envirotech, Agritech, and we had a huge amount of interest in our air conditioning condensate capture and treatment system. So this is something that we're really, really very proud of as well. And we are able to demonstrate that we can treat this water to a hugely high quality, and there's a big demand in the market for this, and it can be reused up to very high value reuse. And this is something that we're looking at further developing and bringing towards the market. So another just brief case study, because I know I could talk about what we're doing in the Water Centre for a very long time, because it's all very exciting. But just in terms of human health, so we're very, very focused on the human health impacts of the whole water process. So one study that we looked at recently was in terms of cyanotoxins, cyanobacteria and cyanotoxin. And this is something that in the region can be something that is worrying. So you may have heard about red tide or algal blooms. And this is something, because we have reasonably warm seas in the region, this is something that can be an issue, and they can impact on desalination plants and potentially not be removed during the water treatment process. So once the algal bloom can form, which you can see in the middle here, this is a picture of red tide, not in Qatar. There have been some instances of red tide in Qatar, but this particular one is not. These cyanobacteria that can grow as part of the algal bloom can produce cyanotoxins that are detrimental, not only to the environment, but also for risks to human health. So some of the kind of causes of that: excessive nutrients in the water. So this can be from shipping, they can be from discharge of treated sewage effluent that hasn't had all of the nutrients removed, from agriculture, so application of fertilizers to land and then runoff into the marine environment, for example, can be a problem. And it can be very, very dangerous to human health and to the environment, and can have a lot of damage to the immune system, lungs, nervous tissue. So it's definitely something that has to be carefully monitored and controlled. There are regulations in place globally in terms of limitation of cyanotoxin, but it's not something that is really typically monitored in many countries where there aren't regulations in place. There have been harmful algal blooms recorded around the region, and these are just some of the historical incidences, isolated incidents. So there have been a few in Qatar, but you can see that Oman has suffered significantly with incidences of harmful algal blooms in the region. So what we looked at, and something that we're really interested in the Water Centre, is the development of technologies that can really be used for the protection of human health and the environment. And one that we're very interested in is the use of advanced oxidation processes. So these are processes that will break down contaminants that are in water bodies. So it can be in drinking water, or it can be in treated sewage effluent, or it can be in treated industrial water. And what we found is that we could implement these advanced oxidation processes, so using ozone hydrogen peroxide, and we were able to really have a really good impact on the removal of these cyanotoxin type compounds. And what we did find when we compared these with the traditional disinfection methods for drinking water treatment, which is chlorination, that really the chlorination did not perform well in terms of cyanotoxin removal. And really it was the oxidation with ozonation or with other advanced oxidation processes was far, far more efficacious in terms of protecting human health. So this is something that, in conjunction with all of the other stuff that we do in QEERI, so we look at things like being able to see, you know, predictions of if there's an algal bloom in a certain place, will it impact on the desalination plant, or will it impact on the drinking water treatment system? And you can put an early warning system in place, and then you can look at, do you have to implement these type of advanced oxidation processes in the drinking water distribution system to make sure that you're protecting human health. Another thing that has a big impact on the environment and on human health is, because this whole water cycle is circular, what we do have is, when you have human ingestion of pharmaceutical or personal care products, we do see them cycling around in the environment when they're not easily broken down in wastewater treatment processes. So something that we're very interested in is these kind of emerging contaminants that could potentially impact on human health or on the environment. So PPCPs is personal care products, pharmaceuticals and personal care products, EDCs is endocrine disrupting compounds. And we are looking at the presence of micropollutants in the water bodies across Qatar, particularly in treated sewage effluent. So when you take pharmaceuticals, obviously what happens, even something like, for example, I'll give you an example, when you have a muscle strain, what most people tend to reach for is something like Voltarol gel, so like a gel that you rub onto, you know, your sore back or whatever. And the active ingredient in that is a non-steroidal anti-inflammatory called diclofenac. And diclofenac is regulated in some areas in the world, but not in all areas. And it has been implicated as being very, very detrimental to the environment. It's been blamed for a decimation of the vulture population in India. And it is not broken down in wastewater treatment plants like most pharmaceuticals. They're just not designed to actually break down in the wastewater treatment plants. They're designed to persist because they need to do that to do their job in the human body. So they're not designed to break down easily. So there's been a huge increase in the environmental detection of pharmaceuticals. And there's a big risk to the aquatic environment, to fish, to crustaceans, to, you know, and they bioaccumulate up the food chain as they are not broken down. So it's really something that's really important to look at, and it's something that we have a big focus on. So you'll see these in globally across the world. You will see these type of micropollutants, antibacterials, hand sanitizers that have compounds like triclosan in them, hugely persistent in the environment. They just don't break down. So this is something that we are really interested in. And a lot of these things are termed endocrine disrupting compounds. So they have an impact on the human body, particularly in reproduction. They can be very detrimental. They have been linked to changes in fertility of the human population, and also in the flora and fauna. And not just things like pharmaceuticals, but also things like sweeteners. So things like sucralose, we see not breaking down in the wastewater treatment plants, and they're just proliferating throughout the environment. And they've been shown to have really an impact that would never have been thought of when they were being designed. I mean, they are industrial chemicals that are being designed and marketed for use as a sweetener. And these are consequences that were certainly unintended. So they are cycling around in the environment, and what we try to look at is the monitoring of these micropollutants, and also the evaluation of technologies to try and remove them. And as I said, the wastewater treatment plants here are fantastic. We've installed a pilot wastewater treatment plant that looks at these advanced oxidation processes. So looking at moving on from our cyanotoxins research into these micropollutants. And we have, in terms of screening, we have detected most of these. Now, one of the issues is that these are not regulated for. They are coming under the radar in other areas of the globe. So there's a big focus in Europe now on endocrine disrupting compounds in the aquatic environment, and other micropollutants like plasticizers, pesticides, things like that. We see them in very low levels. So if you are to look at one compound in isolation, you test for that, you say, well, that's a very small concentration. Sure, that couldn't possibly be harmful. But when you look at the cocktail mixture that humans are being exposed to, the reality is that we do not know what the effects of chronic, long-term, low-level exposure to these pharmaceuticals in the environment, in our food and in our drinking water is. We just don't know what it is. And it's really, really, really important for research institutes like QEERI to focus on doing the science, getting the data, and using that to influence how our countries are run and how the regulators will build the policies around what has to happen. And then at the same time, the technology development to address these challenges is really important. So as I said, we've installed an advanced oxidation pilot plant at one of the wastewater treatment plants in Doha, and we have been operating that for the last few months, and we're looking at monitoring for these pollutants and looking at removing them. So just giving some general results. So ibuprofen is a pharmaceutical that everybody will be very familiar with, really, really common and not well broken down in your standard wastewater treatment plant, but we've been able to achieve up to 80% removal of ibuprofen using these kind of advanced oxidation processes. But we have found a lot of compounds at very, very low levels, and this is something that we're investigating further. So just to give you another quick overview of things that we're doing as well, QEERI has been involved in looking at the SARS-CoV-2 in the wastewater. So we have been able to sample the wastewater throughout the pandemic. So starting from last May 2020, we started sampling wastewater to look at the presence of coronavirus in the wastewater. And this is a really, really powerful tool that can be used to try to monitor the health of a population on a population level. So we looked at the 5 major wastewater treatment plants in Qatar. They serve the vast majority of the population, so they serve as a way to monitor the health of the whole population. This is something that has much wider implications. So at the moment we're looking for SARS-CoV-2 to get an idea of the levels of infection circulating within the population, and we can see whether the levels of infection in the population are increasing or decreasing, whether or not there could be hotspots of infection within the population, for example. But it can be used for much, much more than that. So biomarkers of human health, so things like diabetes, things like alcohol abuse and illegal substance abuse, very, very common use of wastewater-based epidemiology across the board, across the globe. So this is really, really interesting. So we can get to see the population without having to go out and swab large numbers of people. We get a pooled estimate of what's happening in the population. And the other thing that we can do is with new sequencing techniques, we can actually look for the presence or the emergence of new variants within the population just by sampling the wastewater, sequencing and seeing what variants are present. So we have been able over the past few months to see the rise and fall in the UK variant. We've been able to see the rise and fall in the South African variant by using these next generation sequencing techniques. So it's been a really, really important study. It's been a really, really important collaboration. The Ministry of Public Health, Hamid, ourselves at QEERI, Ashra, Will Cornell have really come together to do this really important work that has been able to inform the public health strategy. So that's just some of the results from that. We were able to track quite well last year, and we've done the same this year with the second wave as it's come through. So it's really important in terms of helping public officials. So I had promised to talk for about an hour. I've gone a little bit over that, but not too much. And as we said at the start, I hope I've given you kind of food for thought, and the key thing that we really want is to hear from you and ask some questions, and let us know what you're thinking, and we will try to take that on board and try and answer any questions you might have. So I'm going to try and stop sharing. There we go. Okay.
There you go. All right. Thank you so much for that very, very insightful presentation. You've covered so many different water-related topics that everyone is definitely going to have something to think about today. So we do have a few questions, so I'm going to read them out to you, and you can share your insights on it. So one of the questions we got early on is that, do you know of any international company or organization that's working towards focused on sustainable water conservation?
Yes, is the short answer. Do I know of any international companies? I mean, there's piles of companies, so there are companies from small startups and SMEs that look at installation of solar driven desalination systems in developing countries. Even at QEERI, we're currently looking at we have some sets of materials that we've developed that are really good for filtration of water that can be used as point of use water filtration systems. So if you're at off grid and you have a water source available, that you can safely treat that water with zero energy, basically with a small hand pump. And these materials that we've developed at QEERI will take out the bacteria and will take out chemical contamination, for example. And there are lots of companies that do that. And there are companies that look at, for example, solar disinfection in developing countries, which are really, really basic but really, really powerful. So even looking at the impact, like projects I've been involved in before, looking at taking plastic water bottles, filling them from the local river and leaving them in the sun for a day, and it actually disinfects the water. So, really, really sustainable options, low energy options that can be used in the developing world. And then there are obviously companies that will focus on countries like Qatar. So there are a lot of companies that look at developing more sustainable solutions. QEERI is a research institute. We look at bringing things up to a certain technology readiness level, and then we look at partnering with companies around the world that can take that forward towards the commercialization. So, for example, making wastewater treatment processes more efficient. One of the major energy uses in wastewater treatment, in biological wastewater treatment, is provision of the oxygen to the microbes that basically break down the contaminants in the wastewater. So when you see a traditional wastewater treatment system, you'll see big, huge tanks of wastewater that have a surface aerator. So they'll have a kind of an arm that turns around and agitates the surface. And they'll typically have oxygen or air blowers under the surface that pumps oxygen through. And those blowers are the biggest use of energy in the entire wastewater treatment plant. They're massively energy intensive. So there's been a lot of companies that have looked at developing systems that will be more energy efficient. So one example of that is companies that make membrane-based bioreactor type systems. And even ones that have developed processes where they change the whole thing around, and instead of aerating the microbes themselves, they use these like oxygen permeable membranes, and the microbes grow in a biofilm on the membranes, and instead of putting the air through the water, they just put it through these membranes, and it permeates out and feeds the microbes, and they're growing in a layer, and they break down the contaminants, and then it's easy to take out the water, the clean water, with another type of filtration membrane, using an ultrafiltration membrane. So there are piles of companies out there. I mean, the water industry is a big industry with a lot of companies in it. So I mean, the short answer is yes, and the long answer is too long. So.
Yeah, thank you. That was a lot of information, but of course I'm going to plug in QEERI here. We do a lot of obviously water related research. We are also, like Dr. Jerry said, have pilot plans, and we have teams building filtration systems, teams building cooling options, and we're working with national level stakeholders like AHRMA, like QWC, to see how we can help Qatar better. I have another question here, and this is more of a QEERI question as a whole, because it has a corrosion component. I know Dr. Hanan Farhat, our Senior Research Director for corrosion, is listening in as well. I don't know if she has the ability to, sort of unmute herself and give a bit of the answer, and some of it is, of course, water related, so it's more your arena. So it goes like this. So she says, I believe it is a she, says, I'm a chemical engineering student, and she's asking if chemical processes and plants, which have like rusted pipelines under the sea, are they still like considered an obstacle and threat to the water, even if they, are built following the environmental regulations? Dr. Hanan, if you can unmute yourself and, share your insights as well, that would, I'm sure, help the student.
Yeah, so I mean, I think that the question is probably referring to the oil and gas industry, and QEERI is collaborating extensively with the large oil and gas companies here in Qatar, and corrosion is a massive risk, infrastructural risk, and I would say that definitely this is a problem, and it's something that QEERI looks at really extensively. And Hanan can say more about that if she can unmute herself. But
yes,
QEERI puts,
can you hear me?
Oh, there you are, Hanan.
Hi.
Thank you so much, Dr. Hanan.
Okay, just let me get this. Okay, yeah, so it's a bit difficult because it's a process engineering question. So it's mainly looking at the impact of the corrosion that leads to leaks of process fluid into the environment. And in this case, it depends on the process fluid, so we cannot say much, but the subsea pipelines usually are very well corrosion protected. And if there is anything that is rusted badly, then it's abandoned, which means that it doesn't have any fluid in it. If, God forbidden, corrosion increases fast, which means that there is an issue with the corrosion protection, then whatever process fluid that are there, yes, it would leak and it would impact the environment. But this is also depends on the chemical composition of these process fluids. So we don't know, what's in there. So we cannot really give insight on what would be the impact on the environment. But we know if it's an oil and gas product, then the impact will be significant on the marine life and on the environment. I hope this answers the question.
Seham, if you have anything, any follow-up questions, please feel free to, ask, and our brilliant senior research directors will be happy to answer it. That the voice you just heard is Dr. Hanan Farhat. She's our senior research director for corrosion. One of the many centers we have at QEERI to help Qatar in its journey towards tackling brand challenges. All right. Dr. Jenny,
I'm just going to take the chance to point out, I mentioned we're working extensively with the oil and gas companies, and just something that people might not be aware of is that when you have extraction of oil and gas from the subsurface, you take out more water than actually fuel or oil or gas. And this is something called produced water. And what has happened to it in the past is that it gets re-injected back into the wells. And that's something that Qatar has put a big focus in terms of sustainability of the wells. They put a focus on reducing that re-injection to about 50%. So I didn't get a chance to put it in the presentation, but what we're looking at is really looking at that as a non-conventional water resource and what we could do to treat and to reuse that water for beneficial purposes. So you will hear more about that in months and years going forward. But it's something that we're very excited about in QEERI as a whole, and really making the whole industry more sustainable and more environmentally friendly.
All right. So since we had a question from a student, I have another question, also from one of our students listening in. How can we as students help in supporting the water center at QEERI in addressing these challenges? So do you have anything that the students can do?
Okay, so this is a perfect opportunity to mention our QEERI internship program. So QEERI does have an internship program that runs every year. We have really interesting projects that interns can come and get involved in. So I'd encourage you to have a look on our website where you can find the details of that. And maybe Dara, you have the link. So if you manage to get here, you can probably get to the website. We welcome interns all the time, and then we also have one of the key challenges is actually raising awareness on environmental issues. So if you're coming to events events like this, you know, you're clearly already switched on, and something you can do is really pass that on to others. So pass on your passion for science and engineering and the environment and sustainability, and communicate that to others is really, really important in terms of changing public perception and changing the way that society behaves. It's really important. We also have our Young Innovators competition that QEERI runs every year. So this is for school students. So everybody from the age of 6 up to 18 is eligible to take part. So we've run it for the last 2 years. We'll run it again this year. We typically have about 1,000 participants of school students across Qatar. So you can, if you're a university student, you can pass that on to any of the younger people in your network. And again, details of that will go up on our website, and that is again about raising awareness and raising community spirit around the theme of environmental sustainability. And there was one other thing that I was going to say, but it's gone now. Sorry, I'm talking too much.
I'm going to say that it's probably the IC7 conference that's coming up.
Yeah,
so Dr. Jenny actually happens to be the chair of the conference. It is our second time this time, and you know, university students will have competitions and a huge role to play. So please keep your eyes
open registration.
And free registration for undergraduate students as well, and very nominal registration for everybody else. So please make sure you participate and contribute. You know, to IC7 2021, which will happen in November this year. All right, so we have another question, which is, you know, which goes back to everything you spoke about in terms of bottled water. Why is it so cheap in Qatar? Why is bottled water, you know, I mean, you get it for like 50 dirhams. And so is bottled water subsidized in Qatar, or is it just a general practice?
Yes, it would be subsidized by the government. So the price that we pay for water doesn't really reflect the price that it costs to treat the water. And the majority of the bottled water in Qatar comes from Karama, actually. It has some post-treatment processes for remineralization and that kind of thing, and then it's bottled. So that's why it's cheap. So the tap water is cheap, and the bottled water is quite cheap here as well, because it's typically bottled here.
So talking about bottled water, that automatically leads me to another pertinent point, which is microplastics. Is microplastics in bottled water? Because, you know, I mean, these days you even hear about how, you know, baby bottles have that concern. So is that something we should worry about, you know, if you use a lot of bottled water at home?
Okay, so the typical advice for the use of plastic bottles is that you typically shouldn't reuse them for an extended period of time. And it's not just because of microplastics. So where you will get microplastics, and there has been extensive reports published on this, an extensive study done on microplastics in drinking water. Where you will typically get tiny plastic particles is actually from the lid rubbing against the cap, you know. So when you're screwing and unscrewing the bottle, you may get tiny plastic particles. There's been conflicting studies on the levels of microplastics in tap water versus bottled water. The jury is still out on which one has more, but the general advice on the plastic drinking water bottles that you buy in the shop is that you shouldn't really reuse them for a long period of time, and they shouldn't be left, for example, in a hot car, because what you can have is leaching of substances from the plastic into the water, which may be, you know, over the long term, not the best for human health. So in the interest of sustainability, it's typically better, if you can, to have, you know, maybe a stainless steel water bottle, or a hardened, like a Nalgene plastic type water bottle that you can use for a long period of time, and that you can refill from a good water source. You know, so that air to water generator machine at the OCT is great. Go and fill your water bottle there. And you know, as I said already, the tap water, if you can manage it yourself, that's a really good option. You can install a filtration system under the sink in your home that will make 100% sure that, you know, you've got really safe, clean water. So that's definitely a good option.
And also probably cheaper in the longer run if you install the filtration system under your sink. Okay, so going on to the next question. Again, it's related to drinking water, and you know, when we speak to students, especially the younger kids, about the wastewater, you know, treated wastewater, it's a question that often comes up. do you see, maybe in the next 5 years, it becoming, drinking water, like treated wastewater will, I think it's a mindset issue because I can't picture myself getting there. But as a water researcher, what are your sort of thoughts on that?
Well, as I said, water is circular. So all the water that is wastewater eventually ends up in the sea, and then we treat it and we drink it. That's the reality. So,
Okay.
you have to look. Yeah, that's the reality. All of the water that is here on the planet has been through a human body at some stage and an animal body. That is the reality of water. That is just the way it is. So it's quality that you have to focus on, not where it's been. It's been everywhere, everywhere. So it's the quality that you have to look at. And once it's treated to a high enough quality, it's perfect.
It's safe. All right. So what, I mean, what about like the groundwater? You spoke about aquifers and, so is it readily drinkable, as in, is it clean enough to drink if we say dig a well, or does that need to be treated as well?
That needs to be treated. So pretty much all of the groundwater in Qatar is saline. So drinking water will usually have a low level of salt in it. It needs a certain amount of salt for taste. So you want something under about 500 parts per million for drinking water, or 200 parts per million ideally. And the same goes for most irrigation of vegetables and other plants. So most plants don't tolerate salty water well. So what typically happens here in Qatar is there are lots and lots, there's about 2,000 wells dotted around the country that are used for agriculture. And a lot of farms will have desalination systems in place on them to take the salt out of the groundwater. So some of the groundwater is nearly as half as salty as the sea. It can up to that 10,000, 12,000 ppm of salt in it up in the up in various different farms. QEERI actually works directly with a farm that is close to Doha, and we also collaborate extensively with some of the agricultural companies. So we have a number of projects in that area looking at the sustainability of agriculture. So to give you an example, the farm that QEERI has as our test bed, I suppose, we're looking at the integration of sustainable farming practices. Even though, to be honest, in my personal opinion, abstraction of groundwater is really not sustainable. But if we couple that with responsible recharge systems, then it has some potential. So we've been looking at ways to manage the desalination process effectively, looking at the integration with solar. So we've installed solar panels, and we've installed what's called a brackish water desalination system. So for these low levels of salt to remove them. And one of the big water users in agriculture actually is in cooling of greenhouses. So your traditional kind of greenhouses actually probably use about 4 times more water for cooling in the hotter months than is used for watering the plants. So there's a huge amount of efficiency improvements that need to be made across the water cycle in agriculture, and that's something that we are looking at very carefully at QEERI. We're making some nice progress in that area.
The farm project is one that I'm, personally very proud of, the fact that my organization is doing, because we're looking at looking at water resources. We're combining all the abilities that we have at QEERI to, make sure that it's sustainable and it is energy efficient. So that's a very exciting project. If you want to find out more, please go ahead and Google QEERI farm, and I'm sure you'll find a few articles. So I'm going to just take 2 or 3 more questions because we've been here for a while. Going back to wastewater. So we spoke about it eventually will become drinking water, but let's not think about that. How much of it is used in agriculture, and what are the other main uses for wastewater?
I actually put up a slide on that, Dilraj, so I think I think it was something like in 2016 there was just over 60 million meters cubed used across various aspects of agriculture. There was about another 60 used in aquifer recharge projects. run by the municipalities. There was quite a lot used in landscaping and irrigation of public amenities, and there was some use, the amount that's being used in the likes of district cooling and more higher value activities is increasing, and that's what's mandated by Qatar National Vision. And in particular, you know, it is really recognised by the country, and it's very forward thinking in terms of trying to make sure that, you know, looking at avoiding losses of the TSC. So Qatar really does look at this as a really important water resource. And looking at improving the infrastructure, for example, you know, trying to look at addressing issues of leaks and corrosion, and problems with the infrastructure for distribution of both the drinking water and the TSC. So, you know, it is really important to the country, really important to the region, and it's really well recognised.
Okay, so you know, because in the interest of time, I'm jumping straight into the next one. Is QEERI involved in studies to assess the loss of water due to leaks from, you know, the Qatar water transmission and distribution networks, and, you know, general efficiency of the system?
So we do have quite a bit of work in the area of so, you know, the kind of the modern way, or like water sector 4.0, is looking at sensor technology, Internet of Things. So the bare minimum is looking at leak detection. So sensors for leak detection, where you can pinpoint where leaks are taking place within the distribution system, and then being able to put in situ repairs in place, you know, using various different technologies like that. So that is something that we are involved in. We, you know, we're not specifically involved in actually going out and doing leak detection ourselves, but we're involved in development of technologies that can help in terms of improving efficiencies in that way. So this kind of idea of using sensors and using real-time data and really big data, this is something that we're really interested in. So leak detection is the bare minimum, the basics of that. Where we're moving towards in terms of using data for you know, and being able to do something practical with data, that's what we're moving towards. So using it to control the systems, using it to control the wastewater treatment plants and the distribution systems in a really smart way, by collecting data in real time and being able to process it in real time, and using that information in a smart way. So that's where we're focused. We're not, you know, obviously it's the utility's responsibility to look at addressing the issues, but we are helping them in terms of this this kind of digital revolution of the water sector. And then also we are collaborating extensively, for example, with Qatar in terms of corrosion issues, material selection issues that have impacted on the distribution system as well. So I would say yes, we're very much involved, but on a kind of a higher level than just leak detection.
Okay, so before I go to the next question, I'm going to answer one of the queries, because it's about the QEERI internship program. It is open to all students who are residents of Qatar. So as long as you have a QID, you know, doesn't matter if you're undergraduate, postgraduate, you can apply for the internship. You don't have to necessarily be a part of HBKU. All right, so quickly, last year, I promise, what is Qatar's current pharmaceutical pollution level? Would you have any information on that?
So when we look at environmental pharmaceutical pollution, we usually look at fresh water. So most of the data that's available across the globe is in rivers and lakes. And there are some studies on accumulation in soil as well. There's very little information globally, including in Qatar, on contamination of the marine environment. It is something that we're looking at, but we don't have a good benchmark to compare. So I don't have an answer to that question. But hopefully it's you know, this is really quite a new area of research that has only been focused on in the last few years. And while we're at the forefront of that in this region, there is very little baseline data that we're able to compare to.
All right. Finally, this can be, you can probably use the entire 1.5 hours you've used to answer this, but your top 3 sort of, points. How can we reduce home water consumption in Qatar? I think it's a good question to start off on.
Okay, so I mean, it's a question of being conscious of water use, and it is really difficult in a country where you rely on water significantly. So things like being smart, even about what type of, a lot of people in Qatar have these beautiful lush gardens. Even maybe thinking about switching to plants that require less irrigation to create your beautiful lush garden. Have a cactus garden instead of some plants that don't belong here. That's something that can be really done in the interest of sustainability. Things like, being careful in terms of what you do, limiting your use of water where it's not needed. It's thinking about water is the big thing. Thinking about water as a resource that needs to be conserved, not leaving taps running, fixing leaks in your home is really important. Being conscious, even things like when you boil your vegetables, using the cooled water to water your plants is something that saves a huge amount of water. That's kind of the thing that you can do in the home, and every small action like that can make an impact.
Okay, and I think it also goes back to what we started with, like something as basic as brushing your teeth can cost about 4 liters if you're not careful. Just fill a glass, and you're going to save that much water, which you don't even notice is flowing out. All right, ladies and gentlemen, it's about 2 hours since we started, so thank you so much for your patience with us. Thank you so much for listening. I hope it has been a good session. We, like I said, have our IC7 coming up in November. That's our next big event. We hope to see most of you there. That's it from Dr. Jenny, the team, and myself. If I can quickly ask the team if they're comfortable to switch on their camera so that we can acknowledge the faces behind the event, that would be great. Meanwhile, thank you so much. I have shared the the email address in the chat box. So please, if you have more questions for any of our scientists, whether it's energy related, whether environment related, water, corrosion, economics and policy, please reach out to us and we will make sure our scientists are available to talk to you about it. Thank you so much. And I think that's pretty much it. Good night. Bye-bye.